Today we're going to be learning how to add and remove rows and columns here inside of a matrices. So technically you cannot add or remove columns and rows inside of R in a matrix. A matrix is what we call non-mutable, meaning that that object itself cannot be actually altered or changed. What you will see though is behind the scenes, we will essentially create a new one and then we'll destroy the old one. For the programmer itself, it will feel like you are just adding rows and columns or removing them. But I just want to let you guys know technically on the computation side of this, on how much it will actually take in memory and processing and all that, which most of you probably don't care about, we're actually going to be creating a copy of itself and then deleting the original one. All right, so let's first review just how we were able to add values into a vector, and then we'll go into how to add values into a matrix itself. So let's first create a vector, and we're going to just create one that is 5 in length. And to do that, we're just going to create A, and we're going to do C for the creation here of 7, 1, 3, 9, and 4. You can use any numbers you want, and then we'll print that out. And as you can see here, we have a nice little pretty vector created. So let's add in a value, and all we were to do to that is take A, and then we're just going to reassign something else to it. And again, we're going to use C here to combine these, and we're just going to say take A and add 8 to the end of that, and we're going to print that out. And as you can see here, we added 8 to the end of that vector. So the length now is 6 values. And also remember, we can add values at the beginning and in the middle. So let's just quickly do that. So again, we're going to take A and we're going to assign back to A. A itself, we're going to take the first 4 values, so 1 to 4, and then let's stuff in there 10 and a 5. And then we want to keep the last 2 values of 5 and 6, and we'll print that out. And now as you can see, we had our original first 4, which was 7, 1, 3, 9. Then we put 10 and 5 in the middle, and then we pulled 4 and 8 from the end of that. So that's a way you can kind of insert into these vectors. And then to add to the beginning, all we're going to do here is just take our C again, the C function, add 5 to the beginning of A. And as you can see here, we took our original series from up here. We added a 5 at the beginning, and then we have our 7, 1, 3, 9, 10, 5, 4, 8. So that all works out as well. But the real takeaway here is that we didn't actually change A. We overwrote it. And again, this is not going to be that critical for those of you that are like just doing simple model development, like I've done a lot of my career. But when you start to get into really massive iterations or really large model developments, even on the model development side, it can be very frustrating because it will start to bog down and be really slow. So kind of understanding how these pieces work and how it's not actually just changing a piece of A, it's actually overriding and creating a whole new thing. It's just an important aspect to kind of keep in mind as you're programming. So now on to matrices. For matrices here, we are going to be using the rbind function and the cbind. And as you can imagine, rbind is going to be row binding, so adding in new rows, and cbind is going to add in new columns. So to get this going here, let's first create a matrix. And we're just going to call this one Z. And again, we're going to use our C function to create this. And we're going to set this in row equals 3. And in call is going to be equal to 4. And then we're going to print that. And as you'll see here, we have 4 columns, 3 rows, and we have this nice little pretty matrix here, which we're going to add some rows to. So to add in a column, we're going to try here, we first need to create a column that's separate so we can add it in. And we'll just call this 1, because I'm going to make a whole column of 1s here. Again, our matrix has 3 rows or 3 values per column here. So we're going to create a vector that has 3 1s. And I'm just going to type these in real quick. And when you run that, you can see in the top right here, it creates just values because it's a vector, not a matrix yet. And it's going to print out just 3 1s. And now we're going to add this vector to the matrix Z. And to do that, we're just going to say Z, cbind, Z in 1. So we're just binding the original matrix and just adding it together. This is basically the exact same thing that we were doing up here with the vectors. That's why I was just showing you how to do that, because you can use these in very similar ways. But instead of adding in values specifically, it adds in entire columns or rows here. So let's print that out. As you can see, it creates this new matrix itself. It does drop the column headers of the autos of 1, 2, 3, 4, but it does add in the names here. This is critical for statistical programming because often I will start to revert things by names. It is nice and easy and cleaner to have names on everything. I have not been adding names just to create simple examples for programming, but just as a note here, it will save the actual name of the new columns that we do add in. All right, so now to add in a row for the row example, we're going to need 5 values here because we added in that new column. So let's just create a vector called 2, and then we're going to assign to this 2's, and we need 5 of those. So we can count 1, 2, 3, 4, 5 from the original table. If you put the wrong amount in, it'll just throw an error and say like, hey, this doesn't work. This is not the right fit here. So let's create that vector. And then we're just going to do rbind. So now in cbind is doing the columns. We need to add a row in here. And all we're going to do is add in our matrices Z, add in our new vector, which is going to be 2 here. And we're going to print that out. And as you can see here now, we have 2 on the bottom here, and is added a new row into that matrix. Okay, so now we're gonna learn how to drop rows and columns. This is really like a subsetting operation. Just because we're gonna be taking that, we're gonna be removing something and just taking a subset. So we're just kind of shrinking things down. Okay, so to drop a row here, what we're going to do is take Z and we're gonna assign to it Z itself. And then remember that we're gonna have a comma in the middle, and this is gonna be the rows, and this is gonna be the columns. That's what the code is set up to do. And so we're just going to take C and we're going to say 1, 2, and 4. This is going to take the first, second, and fourth row. So what we are doing is we're going to drop the third row. So it should hypothetically take out this one right here with 8, 7, 3, 20, and 1. And if we print this, right, it has 7, 1, and 2. 7, 1, and 2, and we did drop out that row of 8s there. So that is how you would go about dropping out a row. Now let's drop a column, and in this case, let's just drop the last column. And so what we're gonna wanna do is look at our table here. Let's see, we'll keep 1, 2, 3, and 4. And so to do this, we're gonna take Z and we're gonna assign back to Z, again, using the square brackets, nothing in the rows. We're gonna keep all the rows as is. And then we're just gonna put in here the specification of which column numbers we want to keep. For practice too, if you had a really, really large matrix itself, sometimes you might have like 1,000, 2,000, 3,000, and you've been doing calculations on the end of it and you want to drop the last column off. Let's just do 1 and then use the colon here because we just want to keep 1 through 4. You could subset this out like if you had a larger one and then do like 6 through 10, and this would drop columns 5 in the middle here, but our matrices is not that big. And as you see here, let's print out Z and we'll run this. It now keeps columns 1 through 4, 1, 2, 3, 4, but it did drop that 5th last column there. So these are pretty simple functions here. Again, just going back through that, when you have vectors, you can use just the C function, and you can start to add things in with C. But when we move to matrices themselves, we just have to change the function again and do cbind and rbind for columns and rows. And you can basically do the same kind of operations here to be able to add and remove matrices. And again, the takeaway here is that we're not technically adjusting and creating that object as itself. We are actually creating a new object, but it's just overriding it and doing some computation on the back end. So if you found this video helpful, don't forget to like, share, and subscribe. And as always, until next time.